Hi guys, my name is Arun and welcome to my channel. This series is a series of tutorials on Fortran programming. Now, in the last tutorial, we were in the middle of, you know, a function program wherein we were trying to calculate trigonometric identities, and in that we are using arrays. We are using the intrinsic trigonometric functions and arrays to verify these. Now, the last part, what we did is that we calculated the sine values, cosine values, tan, cosec, secant, and cot, and we just printed how the values of x and y looked like for all the values. Now what I did in this program, I just made some slight modification, not a modification but a slight change. What I did is I introduced a new formatting symbol called this 15 format symbol was already there. I introduced a new format called as format 10, in which I represented the value. I am representing two numbers, f10 10.4 and f10.4, with with 5 spaces between them. Okay, and then what I'm doing, I opened a new file called as sinex.txt, and inside, while printing them on the screen, I'm writing these values to the file. Okay, in the format in 10, I'm writing these values to the file sinex.t using this unit 1, and with the format given by format number 10. Alright, now once this is done, what I'm doing, I'm just closing this file up. Okay, now if I were to compile this again, okay, Fortran, build this again, Fortran, this is trig underscore ident.f90 minus o with that trig. Okay, click enter. It should be fine. We get an LX. Ignore this text because I just tried this out earlier, so I can just remove this up again. Sinex.txt and then click ls. Yeah, ls. Now I run this file trig.exe. It's printing up. Okay, let me just rise this up. It's fine. Now we just printed up all the values of the sine function from 0 all the way till 360 degrees. Okay, while this also happened, let me clear the screen. It generated a sinex.txt text again. Okay, now I just use this with Genie. I just open this file. Okay, okay, let me just minimize this, and as stated before, as shown earlier in the tutorial, it generated the value for sin x for all the 101 points. Okay, and now what we do, I just close this. We'll come back here, and what I'm doing right now, I'll just add a few more variables here, the same category. Okay, this will be sin 2x, cos 2x, okay, tan 2x, and then secant 2x, and then cosecant 2x, and then okay, sine, cos, tan, secant, cosecant, and cot 2x. Okay, that being added, what I'm going to do is that I'm going to find the square of these. So what I do is that sine 2x equals sine x power 2. As simple as that. Now if I just copy this again, this is cos, this is cos, okay. And now if I just do this again, this is tan, and this is tan again. Control D, yeah. Cosecant x, cosecant x, control D, secant x, secant x, control D, control D, and then cot x, this is cot x, okay. Now the sign of this is this. The sign, now let's just check the sign value first before we do all this stuff. Now the sign of this is this, okay. And now let's create another format called as another 20, okay. I'll just place this again, 20, okay. The sine square of this is this, and what I do is that I just copy this again, 20, okay, and then I just put sine 2x, okay. Now this being done, what I'm going to do here, so here I'm just writing the sine of x will be sine x, and here the sine square of x will be sine square of x will be sine square of x, and that I'm printing it over here. Since this will obviously work, okay, since this will obviously work, I'll just comment this out since we already tried, and this will obviously work, but anyway I'll keep it over here so that we can just have a look at it, okay. And now what I'm going to do is I'm going to write this file again in a different format. I'm going to keep the overall structure the same. What I'm going to do is that I'm going to write f10.4. I'm going to save this. Here, with this format being the same, I pass the other variable sine 2x of I, okay. Now if everything works out fine, this should work well, okay. ls, okay, fine. That extension should, it's saved and the execution and building is fine. ls. Now if I just try trig, okay, the sine square of 360 degrees is this, and if you notice it worked fine because we don't find any negative values, so this looks fine, okay. Let me just raise this a little bit, yeah, so that we can have a good look at it. It starts here, and we notice all the values are positive, and none of them are negative, so it's successful. And we just list all the files we have. We have this sinex.txt to ensure that it's got to have a look at it. Let's type genie and then sinex.txt, and voila, there you have it. Now first column corresponds to the value of x degrees, second value corresponds to sine x, and third value corresponds to the sine square of x. Now before we go on further, okay, there is this nice little plotting tool I like to show you guys. Called as GNUplot. Now this was not actually my idea. This was actually an idea given by in one of the tutorials I followed to learn Fortran. I'll just show you guys in a minute. I'll just pause this video right now. I'll show you the person from source from which I learned this. Hold on a second. Hey guys, welcome back. I paused this video to show the play from tutorial section from which I learned C programming. I learned Fortran programming from the basics. Okay, there is this person called as Alan. Okay, he released a set of tutorials under the name Hexafoil. Hexafoil. Okay, and he has a lot of he doesn't have much of videos, but he just has quite a few number of videos on his list. And in one of his videos, especially this one, and in this one and this one, he kind of introduces to the concept of, he kind of introduced me to the concept of GNUplot and all, how to use GNUplot to and how to combine GNUplot and Fortran and all to run plots simultaneously. Okay, and all. Okay, I'll just close this. I'll just minimize this, and we'll get back to our discussion over here. Okay, we'll be. I mean, I'm not going to. I'll admit directly that I learned from him, and I don't mind saying the source of it, because I believe that nobody learns completely on their own. Everybody needs a little motivation, help, and that person, Alan, who gave the tutorial section through this profile Hexafoil. Okay, through this user profile Hexafoil, I'm really thankful for him, because he gave me a quick shorthand introduction to Fortran, which I'm really grateful for. Not only him, there are many people, but he's one of the instrumental people, so I thank him for that. And I kind of learned a lot from him. And thing is, let's have a look. Let's use GNUplot to run this. Now I just use a terminal. I create a new terminal instead of having it here. Okay, I just go to the folder wherein we kept there in Fortran tutorials. In that in that our files are in trig identities, so cd, it's in trig identities ls. There we have it. Now the sinex.txt is available. Now before we go ahead with that, what I thought of doing is that install GNUplot. Okay, some of you guys might know what GNUplot is, but for those of you guys who don't know, GNUplot is actually a very simple program. Okay, developed for making instantaneously very quick plots, very quick plots that goes hand in hand with compiled languages like C, C++, and Fortran. These were actually made to make plotting easier without the need of any interpreted languages. See, the problem with compiled languages is that they have very poor plotting features. Their plotting features are really hard to learn, and I don't know whether there are any plotting features in Fortran, but in C there are plotting features, but those are really hard to learn, in which you have to take care of each and every bit. Okay, so instead GNUplot, which I found from Alan, and after little Google search, I found it really easy. Now to install GNUplot, what you have to do is, if you are in Ubuntu, type sudo apt get install, okay, GNUplot or GNUplot, whichever you call it, and click enter. It'll ask for a password. Just enter your password, and we'll just read all the files that are available, link it, and for me, since I already have GNUplot, it just shows that GNUplot is already in the latest version. If it's not available, what you have to do is that it will just show all the list files that are available. Click yes and go on with it. And when GNUplot is fine, what you have to do to check whether it's installed properly, okay, what you have to do is that type GNUplot and click enter. Now if you get an explanation like this, you get a message like this, and you get a GNUplot terminal like this, a GNUplot command prompt like this, then you're fine. Your GNUplot is working perfectly fine. If you don't get it, then you have to run this. For Mac users and other Linux users, the installation procedure for GNUplot is more or less the same. Maybe you just have to change that sudo permissions and that apt-get to yum-get or some other relevant command based on Mac and all. And for Windows, GNUplot is a little difficult to install. It's not as straight as installing in Linux or Ubuntu or Mac. If you guys remember my first tutorial in the introduction videos, I mentioned that you can use Sigwin or MinGW and all to install GNUplot. You have to do that for Windows users to get GNUplot installed, or there might be a GNUplot version especially for Windows. I haven't checked it, but it's worth a try. Now what we do is that we just click exit here, okay, and now let's click ls. We are here. We'll click GNUplot again. We'll go to this terminal. Okay, now what we can do is plot now sinex.txt. This, I think this has to be in double quotes if I remember right. Sinex.txt, let's see, as 1:2. Okay, that as is not required, but anyway, you get a nice little plot. You get a nice little plot of sine function. To make sure this is perfectly fine, you guys can zoom. If you guys can zoom this out, the function is very nice, very nice. By the way, you can still use any other plotting languages or programs, or interpret languages like MATLAB or Python or other packages. That's your choice. It's perfectly your choice and perfectly fine. You guys go ahead with it. I just close this up. Okay, let me just replot that again. I think this as is not needed. Okay, this works fine. I think we need this colon here. That's what it's saying. Okay, somehow it's plotting. For some reason it is plotting fine. Okay, now what I do is that set grid command, and then let's see, expected. It's working fine. Now on this, if I were to plot cos function also, the other function also, let's see how this turns out to be. I plot this. Okay, unfortunately it doesn't plot. It doesn't plot multiple values, I suppose. Anyway, let's have a look at this. So the function, our objective as of now is achieved. We are getting the sine function plotted perfectly. Okay, now I'll just close this up. We can do the same thing here. Thing is, I opened as individual terminal because it's easy to process and all. Okay, let's close this up. Now our sine function is working perfectly fine. What I do is that I just remove this formatting. Okay, I just remove this formatting. I just mode Control D, and I comment this out. And comment this out. Let's save this, and I will take this out of the equation. Control D. I'll comment this out because this is working really fine. I'll just remove this off to print the sine square function. Yeah. Okay, I thought I make a mistake. Okay, fine. Well, now what I'll do is that I'll run this file again. /trig. Okay, it works fine. I click ls. Okay, the sine function this text should be there. Genie, if I just type Genie and then sine text. Okay, there you have it. All of them are positive values. Now let's have a look at this in GNUplot. Okay, now we'll open this in here itself. Oh, hold on, I'll be back. Sorry guys, my friend just called. Okay, anyway, coming back, let's open GNUplot, and then here let's type this command. Let's see how this works, and there you have it. Perfect. You have the sine function, you have the sine square function properly dealt here. Okay, now this being said, our calculations are working fine. We can just exit this out and close it. Okay, and now this being said, our sine function and cosine function, all these functions are working fine. Now I'll stop this video here. In the next video, I'll stop this because it's getting a little bigger. Okay, in the next video, we'll finish this trigonometric stuff and we'll verify this plots in GNUplot by mix and matching these values and seeing how this, and by proving this trigonometric identities in a graphical manner. Okay, thank you guys for watching. See you guys in the next tutorial, and until then, please do subscribe. And next tutorial, I'll just post a little link or so I'll show you a web page wherein you can learn a little about GNU Fortran and all. Thank you guys for watching.